You can use matrices to solve a system of equations as well. So if we have a 3 equation system here with 3 variables, you can write it as an augmented matrix. So an augmented matrix just takes the coefficients. 3x, you just write 3. Negative 2y, you just write negative 2. Plus z, that means there's a 1 in front of the z, so you just put a 1. Equals 5, so you put a 5 over there. I like to put a line down where the equal sign would be. Some people don't do that, but I like to use that. So you write all of the information from your system in augmented matrix, and then we can use that to solve. And mostly at this stage it's just less writing, because you don't have to write all the x's, y's, and z's. So let's solve this system as a matrix. So first let's write it as an augmented matrix. You only write the leading coefficients. So 1, negative 1, 3, and it equals 4. 1, 2, negative 2, and 10. 3, negative 1, 5, 14. So again, I'll draw my equal sign line. Now, our goal to solve this, just like when you're using equations, is to cancel out the x's in 2 equations first. So we need a 0 here and here, and then we'll combine those two to cancel out the y's in the bottom equation. So we'll have a 0 here. You have this triangle form of your matrix that's called row echelon form. So the first goal is to get a 1, which we have, so we can leave that alone. Next, we're going to try to combine 2 equations, row 1 and 2, to cancel out the first number. So let me rewrite our first row. Now we're going to combine rows 1 and 2 to cancel out our first number. So to do that, we're going to do row 1 minus row 2. So we have 1 minus 1 is 0. Negative 1 minus 2 is negative 3. 3 minus negative 2 is 5. 4 minus 10 is negative 6. Now we're going to do a similar thing to cancel out the x term basically from our third row. We're going to do row 3 minus 3 times row 1. Row 3 minus 3 times row 1. So if we multiply negative 3 to row 1, we get negative 3, 3, negative 9, negative 12. So really what we're going to do is we're going to take this bottom row 3 and add with our scratch work right here. 3, negative 3 is 0. 1 and 3 is 2. 5 and negative 9 is negative 4. 14 and negative 12 is 2. So now that we've canceled out the x's there, we're going to combine our 2 new equations, 2 new rows, to cancel out the second number, the y term. And another thing that we're going to want when we're writing this out, you want to have a 0 and a 1 right here to get it into row echelon form, or triangle form. So we need a 1. So in order to do that, you can take either equation, it doesn't matter, either of our two new rows, but we need a 1. So since this is a -3, to get a 1 we could divide by -3, but -3 does not go nicely into 5. So let's look at our other row. We have a 2, so we can make that become a 1 by dividing everything by 2, and our other numbers do divide by 2 pretty nicely, so let's go ahead and do that. We're going to divide by 2. So -4 divided by 2 is a -2, and then 2 divided by 2 is 1. So that's our middle row. We still need to combine these two rows though. I was just doing kind of two steps at once. We do need to combine these two rows to cancel out our second number, the y term. So to do that, we need a common multiple. So between 3 and 2, we need them to both become 6s. So we need to multiply row 2 by 2 and multiply row 3 by 3. That way we get a -6 and a +6. We just have to add them together. So you can do some scratch work. Multiply by 2, and you would get -0, -6, 10, -12. And when we multiply by 3, we get 0, 6, -4 times 3 is -12. 2 times 3 is 6. So we need to combine these two rows to cancel out the y term, the second number. So we have 0 and 0. -6 and 6 is 0. 10 minus 12 is -2. -12 and 6 is -6. And similarly to what we did here, we want to start with a 1 for row echelon form, so we need to divide by -2. So dividing by -2, I copy down our other rows first. Dividing by -2, we get 1, and -6 divided by -2 is 3. So now we have row echelon form. We have 1s going in descending pattern and 0s below them. That's row echelon form. So from here you can use back substitution, because this tells us that z equals 3. Plug that in, we would get y minus 2 times 3 equals 1, so that's y minus 6 equals 1. Add 6, we get y equals 7. And then substitute y and z into our top row. That'd be x minus y, which is 7, plus 3 times z, which is 3, equals 4. 3 times 3 is 9, minus 7 is 2, so we need to subtract 2, we get x equals 2. So our solution would be 2, 7, 3. I also want to show there is a way that you can use this on your calculator. You can make your calculator to actually do the work for you. First we need to enter it as a matrix. So second matrix. And we need to edit. So we'll go over to edit, select matrix A, just because that's the first one, it makes sense. We need to enter it as an augmented matrix. So there are 3 rows and 4 columns in our augmented matrix. So 3 by 4. I need to change mine to be a 4. And then just enter the augmented matrix. So 1 negative, and it goes across each row first. 1. If there's already data in there, it'll just type over it when you type, so that's okay. The -1 is next. Enter. 3 and 4. Row 2 is 1, 2, enter, -2, enter, 10. And row 3 is 3, enter, -1, enter, 5, enter, 14. So once you have it all entered, you have to quit. So second quit. And if you go and select matrix, if you just select matrix A right now and not do anything with it, just push enter to select matrix A, and enter again. It will display the matrix for you. That's a good way to make sure that you entered it correctly, because that would be an easy way to make a mistake. After you do that, you go back to matrix and then go to the right one menu, one tab. And if you scroll down, you'll see right down here, mine's option A, REF. It stands for row echelon form. So if you select that option, it will convert whatever matrix you want to row echelon form. So then you just have to go back and select matrix A. Press enter. Now, row echelon form isn't always the same for every matrix. So since this has decimals, you can get rid of the decimals by just pushing the math option and going option 1 for fraction. It'll display them as fractions instead of decimals. So we can see that our bottom row, 1, 3, is the same, but the other 2 rows the calculator did differently, so it's hard to check. So let's do another example by hand. Remember, the first thing we need is a 1. So looking at our options here for the 3 different rows, the only one that divides evenly by whatever number's in front of x would be the first row, because everything can be divided by 4 evenly. And it's always nice to avoid fractions if you can. So let's divide everything by 4. So we get 1, 2, -1, and 1. We can just write the other rows out for now and as our augmented matrix, and then we'll start working in the next step. So next we want to combine row 1 and 2 to make a 0. So to do that, we're going to multiply row 1 by -3. So that becomes -3, -6, +3, and negative 3. So if we combine that with row 2, three and negative 3 is 0, 8 and negative 6 is 2, 5 and 3 is 8, negative 11, negative 3, that's negative 14. So we got that by doing row 2 and negative 3 times row 1. Now to cancel out this negative 2, we're going to need to combine it with row 1 and multiply by 2. So let's multiply 2 times row 1. So we get 2, 4, negative 2, 2. So we'll combine row 3 and 2 times row 1. There's 2 times row 1, combine it with row 3. Negative 2 and 2 is 0. 1 and 4 is 5, 12 and negative 2 is 10, negative 17 and 2 is negative 15. So now that we've got zeros in our first column there, we can move on. We're going to combine those two to cancel out one of the y terms, just like solving equations. But first we want a 0 and a 1. We can take either one of these because 2 divides evenly and so does 5. So let's just divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Negative 14 divided by 2 is negative 7. And we can actually, as our scratch work, divide by 5 all the way through here. And when we do that, we get 0, 1, 2, negative 3. Now the reason for that is it'll make combining easy, because now we have a 1 and a 1. So all we need to do is subtract. So we're going to do this row 2 minus this blue row 3 over here. So we have 1, 0 minus 0, 1 minus 1, 4 minus 2, and negative 7 minus negative 3 is negative 4. Now we want a 1 here, so we need to divide by 2. So let's write our first 2 rows. And now we're dividing by 2, so we get 1 and negative 2. So there we have row echelon form. So at this point we could do back substitution and solve. So we'd have y plus 4 times negative 2 equals negative 7. It's y minus 8. If you add 8 over, you get y equals 1. So then we would have x plus 2 times y is 1, minus 1 times z is negative 2. That's going to equal 1. So that's 2 plus 2 is 4. Subtract 4 over 1 minus 4. We get x equals negative 3. So negative 3, 1, negative 2. So you can go a little bit further by keeping it in matrix form and getting to what's called reduced row echelon form. And that's when you have only ones going diagonally. Everything else is a 0. So this becomes a 0, and 0's here and here. So to do that, you just continue to do the same things that we did before, but we're going to use row 3 to cancel out these numbers. So we cancel out a 4. We're going to multiply by -4 and add. So we'll keep our bottom row the same, 0, 0, 1, -2. Now to cancel out the 4, we need to multiply by -4. So it becomes -4 and 8, and add 0, 0 plus 1, -4 plus 4 is 0, 8 and -7 is 1. As you see, we have y equals 1, which is what we got when we back substituted. Then, to cancel out the 1, we just need to add. So 1 and 0 is 1, 2 and 0 is 2, -1 and 1 is 0, 1 minus 2 is -1. And our last step is cancel out that 2, so do that by multiplying by -2 to create a -2 and then add. So we get 1, -2 and 2 is 0, -2 times 0 plus 0 is 0. -2 times 1 is -2, plus -1 is -3. And then we can keep our other two rows, 0, 1, 0, 1, and 0, 0, 1, -2. And as you can see, that does get the same answers, -3, 1, and -2, as back substitution. So when you're done, this final column is just your solutions. X is -3, y equals 1, z equals -2. And you can do that on your calculator. If you enter it as a matrix, so let's edit that 3 by 4. Go back up and we'll enter the original matrix. 4, 8, -4. And 4. 3, 8, 5. -11. -2, 1, 12, -17, and quit. Then we go back to matrix. Now this time when we go over to math, we're going to scroll down a little bit further to RREF, that's reduced row echelon form. So select that and then tell it which matrix to convert to reduced row echelon form. So we'll tell it matrix A, because that's where we just entered. And we get the same answers, -3, 1, -2.